So, last but not least, we are going to look at the identification of an unknown carbohydrate. So, you and your partner will be given an unknown, and you will be asked to determine, to describe it as much as possible. So, in terms of its polysaccharide or monosaccharide, is it an aldose, is it a ketose, any sort of describing words that you can determine about your unknown. You want it to be as complete as possible. So hexose versus pentose, aldose versus ketose, polysaccharide, monosaccharide, whatever information you can glean about your unknown, it should be as complete as possible. So just sort of a few points of nomenclature. Let's say that we have, we're going to look at the Fisher projection, and then the equilibrium that sugars undergo. So glucose, let's just say it's glucose, the Fisher projection of glucose. And this carbon, remember we have the more highly oxidized form, so we have an aldehyde group up here for our glucose. And if we count 1, 2, 3, 4, this is our fourth carbon. That's kind of the culprit. When glucose is in a solution of water, it is in equilibrium with like 99% over here in the closed ring form and 1% in straight chain form. So if we have a chunk of sugar of glucose that's just sitting on a table that doesn't have any water nearby, it's not dissolved in water, it'll be in crystalline form. Once we throw it in water, it's going to go into this equilibrium, but the equilibrium is highly favored to the right-hand side. And so when we're looking over here, here's our culprit. That's where it's forming its ring structure. And we have either the alpha form or the beta form. And these are just, once it closes, the last hydroxyl groups that can either be sticking up or they can be sticking down. And so if it's up, it's beta. If our hydroxyl, our last hydroxyl group is sticking down, it's the alpha form. And so just another point of nomenclature, we'll say it's a glucopyranose. And so pyranose meaning it looks kind of like pyran. And another way to think about that is it looks like cyclohexane if it's a pyranose, except instead of, unlike cyclohexane, it only has 5 carbons in the ring, and then it also has an oxygen. Versus if we wanted it to be, oh, that doesn't look very nice. If we wanted it to look kind of like a furanose, it would be a 5-membered ring. And then gluco because we're using glucose. And so a glucopyranose, either beta or alpha form. And then another point of nomenclature, we can label our sugars as being hemiacetals. Hemiacetals will have, they'll be in a ring, most likely if they're dissolved in water, so R. And then they will have the kind of key carbon will be attached to 1 hydrogen, and then a hydroxyl group, and then an ether group. So if we're looking at this carbon right here, it's kind of like our key carbon. Well, it's going to be this or this, so it'll have 1 hydroxyl group. And then, well, it has its R group right here. So here's its R group. So check. It'll have 1 hydroxyl group, either up or down. Okay, so here's our hydroxyl group. So check. And then it'll be connected to an ether group. So this is actually our ether group because we have OR. We have OR or O and another carbon. And then there's actually, so if, let's just say it's beta. So if we have 1, 2, 3, every carbon needs to be bonded to 4 different things. So there's our hydrogen. Check. So if you're looking at a glucopyranose, if you're looking at any sugar with just 1 OH and then a hydrogen, the hydrogen will probably not be written there. We know it's there because carbon likes to form 4 bonds to things. But a lot of times on hemiacetals you'll see an OH, and then that'll be it in terms of what's hanging out right here. Hemiketals will let's see, not have an H here. They will have 2 R groups. So instead of an H here, you would see another R. So heavy ketals, they don't show up as often when we're looking at our disaccharides that commonly occur in nature, but they still can exist, and there's a name for them. And acetals, on the other hand, we will see often in nature. Acetals will have an OR and an OR group. So let's say we wanted to turn this into an acetal. Instead of having OH here, we will have an OR, where R is any kind of carbon. And then that would turn this, let's say here, this is still our H, that would turn this into an acetal. So instead of having OH, if we switch the H for any kind of carbon, whether it's a whole nother ring structure or it's a methyl group, and down to a methyl group, that would make it an acetal. And last but not least, oftentimes when we're just looking at common structures that we have in our bodies or that we like to eat, we won't see ketals very often, but that would be if we have an OR up here, an OR and an OR, and then 2 R groups. So let's see here, that would, we have OR, another OR, and then we have, instead of this being an H, it would be another R group. So whatever R group you like, whether that's a methyl group or a whole nother ring or a whole nother chain, that would make this into a ketal. So there are several different kinds of structures that we're looking at, and it's most important when they're in a ring form. It doesn't really come into play if we're just talking about just a straight chain form of sugars. That doesn't come up as often. So kind of the nuts and bolts for lab that you'll be looking at is you want to fill in the chart on page 75 beforehand. So this is absolute categorical. This should be done ahead of time. And so in this lab, the directions are pretty glib. We're just telling you, we're giving you an unknown, and you have to describe it as thoroughly as possible. That's the purpose for this lab. The directions are pretty glib. You're given a couple of charts to kind of figure out how to test your unknown, but at the end of the day, it's kind of on you to test out your unknown. And you'll be given different reagents, like Benedict's reagent you've seen before. You'll be given iodine, so you could do the starch iodine test again, like we did with the previous lab. But it's your purpose in life in this lab is to figure out what your unknown is. A couple more tricks of the trade. You'll be heating things in a hot water bath. Get that going right away. You'll have different tests that you can do, and you kind of want to test your standards, which are your known sugars, you know their identities, and your unknown at the same time for each test. So let's say that you're doing one single test in a hot water bath. You want to test all the sugars together, all the known sugars together, as well as your unknown in your hot water bath. And so I would recommend getting a piece of tape, and we normally will have Scotch tape lying around, and then a Sharpie on the tape so that you can remember what is in each of your test tubes. So if you just put like a wax pencil to label your test tubes, that'll wash off in a hot water bath. Also, bumping can occur where you'll start, like the water will start splashing out if you have a lot of test tubes in your beaker. And so you will want to kind of monitor that. Kind of the meat and potatoes of this lab is not getting the right answer, like I know what your unknown is. However, we are interested in knowing how well you write observations. So kind of a goal for this lab for you as a chemist is to make really good, thorough observations. So you want to take observations beforehand. What did your sugar and your testing and your reagent look like beforehand? and then what did they look like afterwards. It isn't helpful necessarily to just describe, well, afterwards it formed a precipitate. Well, okay, what was it beforehand? Was it a gas? Was it in solution? What color was it beforehand versus afterwards? And so look at color changes. So record the colors before and after if you see any color changes. Look at precipitation if it's relevant. And then also look at the timing of the reaction. How long did it take if it's relevant to the reaction? So depending on what reagent you're using, some of the reagents are time dependent. And so if that is the case for the reagent you're looking at, you'll want to record the times. So safety, some of our reagents just already have H2SO4 in them. So some of them, by definition, by what makes that reagent, it has sulfuric acid in it. And so be very careful, wash your hands thoroughly when you're done with the lab. Wash your glassware thoroughly. If you have any spills, wash the spills. If you spill on your hands, wash your hands right away. Just in the interest of this is a really strong acid. So porcelain plates that you'll be doing for some of your tests, they look like this. And what you'll do is you'll take a wax pencil and you can make a little code for the different sugars. So you could have like 1, 2, 3, 4, 5, 6 that you write with a wax pencil. And those will be like sugar 1, sugar 2, sugar 3, and you can make up a code on just like a scratch piece of paper. And so then you'll put in your sugars, a few drops of your sugar, and then the testing reagent. So that's what the porcelain plates are about. However, they are hard to clean. So in terms of like getting the wax pencil off and then just making sure cleaning every circle, these are hard to clean, so soap and water really, it will eventually do the trick, as well as some of the test tube brushes that we have. So just kind of a heads up, that'll be something that you'll want to time for. You'll have to leave time for cleanup for that. And also, so like I said before, you just getting the right answer, well, my, unknown number 32 was glucose. That isn't very satisfying in and of itself. Being able to defend your results is much more important. So knowing that because your Benedict's test, your iodine test, your Molish test ended up a certain way, and then you being able to justify, well, okay, if Benedict's test is positive, that means I had an aldehyde and a reducing sugar. Therefore, we can say that my unknown, since it had a positive test for Benedict's, it must be an aldehyde or some kind of reducing sugar like an alpha hydroxyketone. That kind of reasoning and logic is much more interesting than just saying, well, unknown number 30 is an aldehyde, done. It's much more interesting for you to be able to give the rationale for that. So try to have any written explanations be as thorough as possible, given kind of the rationale, being able to defend your results based on what observations you saw and what the observations mean. And last but not least, when you're done with this lab, the inquiry project that you are going to start to consider, this lab itself is pretty inquiry based. It's pretty, it allows you to investigate however you might like to investigate. So for inquiry, you could do another lab. So maybe, for instance, you instead of looking at sort of like a stock sugar like glucose, maybe we could see what other kind of sugars we have in the back stock room. That might be a lab that you might want to do, or you could also do an internet-based inquiry. And something to think about is that test for reducing sugars is very important in the medical field for testing for diabetes. So if your career is in medicine right now, or if you are going to be in the medical field, it might be interesting for you to do an internet-based project where you just write me a report. And not just, it could be really fascinating to see what you can find out about reducing sugars and why they're important on the internet. So what that would look like is